density of liquids. Okay? This is equal, similar. Approximately equal. As spacing in solids and liquids are approximately smaller, are similar. So let's say the spacing, so let's say the separation in solids is literally close to that of the separation in liquids. So if the same object, let's say water and ice and water, because the separation is close to being similar, therefore the density is also similar. Remember, not equal, similar. Strong forces between particles in solids and liquids maintain fixed volumes of solids and liquids. We also know that in solids and liquids, the volumes are fixed. And this is because there are strong forces involved inside. Meaning the forces are quite not weak, they are quite strong to keep them in place, okay? This is different from strong nuclear force. This is strong forces means it keeps them in place. It's locking the solids into the separation of the volume that are quite similar to each other. In order, because it's fixed, they're able to maintain their volume. So you have a fixed volume thanks to the strong forces. However, densities in gases are much lower. So you're talking about density of gas is actually much smaller compared to these two, which is bigger than density of gas. The reason why it's much smaller, you can say density in gases is much lower, about 1,000 times greater than in liquids, as spacing gases much greater. So, density in gases much lower, as indicated here. As we talk about the spacing in gases compared to liquids is about density about 1,000 times bigger. So, difference about 1,000x. And this is to do with the density. When the density is 1,000 times greater, what can we say is about true about spacing? The spacing is, if this is a 3D object, you got 10, you got 10, you got 10. That is like the size of a cube. 10, 10, 10. So you can say the spacing in gases much greater. So separation of the gases will therefore be around 10 times bigger than the separation of liquids. Okay, remember the L cube in the previous episode, where separation is just L, but volume is L cube. So when X separation is 10x, Y separation is 10x, Z separation is 10x, therefore in terms of volume, you have 1000x, which is the density comparison. Why the density of liquids is around 1000 times greater than density in gases. Rigid forces between particles and solids. So you can say there are some rigid force here. This rigid force allows not only solids to have a fixed volume, they also have a fixed shape. Remember, liquids do not have a fixed shape, they take the shape of the container. So you also have this. Forces of attraction between gas particles are negligible. So when you talk about gases, we talk about two particles. There are forces of attraction. Are negligible. Means very small. As gas fills any space in which it is placed into, because of forces of attraction are negligible, therefore gas can fill any space. Remember, liquid takes the shape of a container, but if the container is half full, you see the liquid not really taking the whole container shape, just taking up to the extent in which it covers. But in gas particle, irrespective of the container, you put gas inside, it literally will fill up all the space. As you can say, a perfume in the room, spray in one corner, and the whole room will be able to smell the perfume. Okay? Difference between gas filling up the whole shape and liquid taking the shape of a container. Okay? So another examples of densities, you have density of liquid nitrogen, and 2 giving you around 810 kilogram meter cube. Yep. And if we talk about air, gas, nitrogen gas, so gas of nitrogen. Good comparison, 1.2 kilogram per meter cube. The difference between solid ice and gas ice, which literally, you got steam and air, you can literally see it's quite different. Gas for 1 by 1 container, each container, 1.2 kilograms, but if it's liquid, it will be much more heavier. Okay? Another good example, what is the density of gas? If it is A, you're going to have around 0.5 to around 1.5 kilogram per meter cube. Compare that with liquid water. As mentioned in the previous video, you're looking at 1,000 kilograms per meter cube. So now you have comparison values to get an idea of the difference between liquid and gases. It's a huge difference, about 1,000 times. Why? You lead to separation in the XYZ component of 10x. A, roughly around most gases around this value of density. Back to liquid again, notice visibly, comparably similar. I hope you understand this video a bit heavy, so if not, please replay this video so that you get good grasp of the numbers we're using and about separation, comparison with densities, and about why certain aspects get a fixed volume, why certain aspects get a fixed shape.